So we're trying to ultimately graph this line. I just want to go through the different ways that there are of graphing a line. So this line is given in the form y equals mx plus c because the y is isolated over here. This is a very useful form of the line because you can very quickly see m, and m is the slope, and you can very quickly see c, and c is the y-intercept, or the point where the graph cuts the y-axis. It's not always given in that form. Sometimes it's given in the form ax plus b y plus c. So essentially all the bits, the x bit, the y bit and the number bit, are all on the left hand side and you have an equal 0. So this form is not as useful. If a line is ever given in this form, it's much better to switch it into this form because then at least you can see the slope and you can see the y-intercept. So because it's already in the useful form, y equals mx plus c, we look at the line here. M is always in front of x, so right in front of x here we can see 2/3, so we know that the slope of this line is 2/3. So quite easy. Second question is, what's the y-intercept? So I told you that the plus c part, which is the constant part, the bit that doesn't have an x or a y, that's your y-intercept, and again we can quickly see that that's minus 10. Okay, so if, like in this question, it's in the form y equals mx plus c, getting the slope and the y-intercept is just a simple read it straight off the equation. But if it's given in this form, where the x, the y and the number are all on the left hand side and equals 0, you need to switch it into this form first, and then you'll be able to read off your slope and your y-intercept. Okay? So, the graph. There's two ways of doing the graph. So, the first way is using that data we've just got. So using the slope and the y-intercept. That's your first way. The second way then is using points. And we get those points by letting x equal 0 and letting y equal 0. Alright? So I'm going to continue this one just so we have the actual, we already have the data for this one. There it is there, 2/3 and minus 10. So I'm just going to get the data for this one. So we take the line, which is y equals 2/3 x minus 10. And for this left hand side, we're going to let x equal 0. So y equals 2/3 times 0 minus 10. So y equals 0 minus 10. So y equals minus 10. So that gives us the point 0 minus 10. You always put your x coordinate first, which came from here, and your y coordinate second, which came from here. Okay, then we go over and do the same thing, but this time we're letting y equal 0. So it's 0 here, 2/3 x minus 10. So we need to isolate that x, so we will take the minus 10, bring it across the equals, so it becomes a plus 10, and then we lose it from here. So we have 10 equals 2/3 x. Then we want to isolate the x, so we're going to get rid of the 2/3 by dividing, but then you have to balance by dividing on this side. So you should just be able to type that into your calculator, 10 divided by 2/3, which is 15, and again write it down as a point. So the x bit goes first, which in this case is 15, and the y bit goes second, which our y bit was 0. Okay, so now we have all our data to plot the point using points, or to plot the line, sorry, using points, and we have our data from up here in blue to plot the line using slope and y-intercept. Okay, so just get some graph paper. Okay, that's better. I was just trying to get it so it was right on the lines. Okay, so we might start with the red one since we've just done that. Okay, so we're trying to plot 0, minus 10 and 15, 0. So the graph's going to at least have to go to those kind of numbers. So 2, 3, 4, 5, 6. So there's 15. I'll just mark in every second one. 2, 4, 6, 8, 10, 12, 14, and then the next one will be 16. Okay, so we can definitely see this is where x is 15, so that's that point there. Okay, and then we go down on the y-axis, so we need to go to minus 10 on the y, so there's minus 1, 2, and then 9, 10. Okay, so again, I'll mark in every second one. So minus 2, minus 4, there's minus 6, there's minus 8, and there's minus 10, which is the one we want. So there's my dot. Okay, so I'm going to try and put a line between these. So starting at minus 10, put a line up there. So there's my line. Okay, and that's plotted one way using the points. So now if I go back up and plot it the other way, using the slope and the y-intercept, okay? So the y-intercept, which is this one here, is your start point. Okay, so we're going to go to minus 10, and that's where we're going to start. So minus 10 was obviously part of my other line as well, so I'm just going to circle it. Okay, so that's where we start. Then you have to take the slope. So the slope was 2 over 3. Now, we know slope is also rise over run, which means the 2 is the rise and the 3 is the run. And you always run first. Okay, so we start at 10 and we're going to run 3. So that's 1, 2, 3. And then we're going to rise 2, which is 1, 2. So I end up here. And if I were to draw a line joining those 2 points, hopefully you can see that we end up on the exact same line. Okay, it doesn't matter that it's shorter because the line extends infinitely in both directions. So regardless of whether you use the points method or the slope y-intercept method, you will end up with the same line. Just to finish off the question, it asks you what the x-intercept is. So if we look at our graph now, I think it's really obvious what the x-intercept is. There it is there. It crosses the axis at x equal to 15. So because we have a graph, that's easy to see. So when you're getting the x-intercept, you can get it straight off a graph if you have one. But it's a bit of a pain to draw a graph if you don't need to draw a graph. So another way of getting the x-intercept, you actually did it over here. Okay, that's where the 15 came from. So to get an x-intercept, a method you can do is just let y equal 0. And that will get you the x-intercept without having to draw a graph.